So without wasting much time, and sit participant again. I know it's someone is a lunch time, but be with me and attend this session carefully. Listen my words carefully because my words very useful for you as well as your students. That is my main mission. Whatever right now I'm presenting in this presentation, that is this image is captured from this internet, and one slide only blank, that is again from my experience. So let us discuss outcome of this 1.5 hour. So again already Acharya sir said that first of all we always know why. So from this 2.5 day, you people attended 7 sessions on this IoT. So as you people very well know, in IoT there are many layers. So right now this my session right now associated with layer 1, that is perception layer. If we again right now ultimate goal in this IoT smart application, everyone wants to prepare smart application. To build this smart application, we have many layers in this IoT architecture that is already discussed by many experts. So right now we are associated with this perception layer, and in this perception layer our main interest is smart application. In this smart application again we have to, our ultimate goal, we have hardwares. You people again heard many hardwares. Our ultimate goal is to design firmware. What is firmware? It is nothing but a binary executable file that is running on hardware. Binary executable file. To develop this firmware, we need some framework. Try to understand this chain. Now there are many frameworks available. That is again we have couple of slide for this ESP IDF. Again yesterday Vitlani sir demonstrated this Arduino framework, and this firmware ultimately run on or dedicated for hardware. Now try to understand, in this hardware we have many sections. We have power supply section, or we have sensors, we have actuators. So in this if we closely look at in embedded system block diagram, so in this block diagram one word is there, one buzzword, system core. So right now to develop this ultimate goal is smart application. To develop this smart application we have to choose hardware in this layer 1. In this hardware again sensors, actuators, system cores, power supply, driver circuitry, all these things. But my agenda or right now my focus is only system core. In this system core again this device is based on MCU base, means microcontroller based devices available. Second one MPU based. So earlier days only MCU and MPU based devices are available, but then after right now SoC, that is called system on chip. Now industry demand some artificial intelligence as well, and for the purpose we have to integrate this GPU and TPU inside our hardware. So here some people use this word SoC or SOM, system on module. So a microcontroller based devices again that we already said, and again some participants having this node MCU available with them. Again, if you refer your curriculum, you have 805 in microcontroller, AVR microcontroller, PEEK microcontroller, and nowadays this ARM Cortex very famous. Similar way, if we announce some names of this MPU means microprocessor, so 8085, 80186, that is a general purpose microprocessor. But if we look at this embedded era or this layer 1, that is perception layer, in this people use this microprocessor like this in the SoC, or we can see here ARM Cortex AX series, means A7, A8. So if you look at our mobile phone, so A nothing but it's for application series. But industry again in IoT demands this SoC. What is called SoC? System on chip. Whatever demand or demanded by this IoT, that is again fulfilled by SoC. So right now this whatever SoC use in our microcontroller or node MCU, again we can use over here as well. So in case of SoC, simple microprocessor, try to understand this definition of SoC, microprocessor. or plus microcontroller plus some either BLE, Wi-Fi, Ethernet. If all these integrated in a single chip, then we can announce it is my SoC. Now what is called my system on module? If we integrate memory, some peripherals with this module, then this is called system on module. And this GPU and TPU is not our today's session interest, but if someone is working in this deep learning, then right now in market, Jetson boards are available, and Google Coral is also available with TPU facility, and it is available with GPU facility. So today's outcome of this 1.5 hour, we are focusing on this SoC. We are talking about, or I'm talking about ESP8266 as well as ESP32, and then which are the programming techniques or firmware development environment available for academic as well as this industry. And then last, I'll demonstrate full this how to install this MicroPython. If you have this once delivery boy deliver this node MCU at your door, and then how to start with this ESP8266 or ESP32, and what is the difference between suppose someone from this computer background or the people attended this Python course and the people know this Python, then what is the exact difference between Python and MicroPython? So with these agendas and with this outcome in our mind, I start my session from this ESP8266, that's followed by ESP32, and lastly I demonstrate full steps of MicroPython firmware installation and firmware development for IoT application, how to develop firmware for IoT applications. So this firmware is nothing but binary executable file that running on our hardware. So this is our agenda or outcome for 1.5 hour. So what is this ESP8266? So again, many experts cover this, but again, I want to throw some lights. That part is missing in earlier session. So Aspressif developed this ESP8266 module. That is nothing but SoC, not only MCU. Yes, definitely SoC is integrated microprocessor as well as microcontroller. It is integrated with TCP IP protocol, and this term is very important: low cost chip with small PCB area and power efficiency. So we are talking about this two module, ESP32 and ESP32. So these are the common features that is available in ESP8266. So if you're talking about only Arduino Uno, then these are these features available in Arduino Uno. But if we replace this Arduino Uno by ESP8266, then we have another feature that is called Wi-Fi. And again, one more advantage, we have 32 bits of microcontroller. Frequency is also higher. And again, let me more focus on this memory, flash memory. In case of Arduino Uno, we have on-chip memory, but here this memory is not on-chip, it is a attachable memory. So don't use this word ESP8266 has on-chip memory, even though it haven't this PWM on-chip hardware support. So advantage is again, we are not focusing on more on this theory because this session is more hands-on, and I already shared this presentation to all. So if you want to go with this one advantage, modem sleep, light sleep and deep sleep. So ESP8266, if you are using full consumption or full on-chip modules or peripheral available, then it consumes 170 milliampere, and in deep sleep it consumes only 10 microampere. That is a very good feature of this ESP8266 at low cost. If types of sleep, again, if you want to explore more about this sleep, then please visit this website. Nice tutorial available with hands-on. The different versions of ESP8266 that is again given by Aspressif. So this ESP01 is again very cheap. This wholesale or retail price is less than 100 rupees. And it has only 2 GPR, meaning is that if you want to control your one fan and light at your home, then ESP8266 is ESP01 is fine for you. Similar way, they develop total 12 modules. So where is 12 one? Here I can see only 11. So where is 12 one? So 12 one is the people use in this in node MCU. So if we again look at this node MCU, then This is your node MCU, because many having some participant having doubt what is node MCU. So node MCU is nothing but a company announcing this breakout board. This is ESP12. This is your breakout board. Again, if you only this breakout board and chip, at that moment we require power circuitry, USB to DTL converter, reset button, boot button, and combination of these all these four together is nothing but node MCU. So why node MCU? It reduces our development time. This is nothing but reduce our development time. And again, if you can see my camera, so one board in my hand, this is FPGA board. So people may use, or people can use that only this ESP12 in any development board. So right now, if we are interested to develop these IoT applications, and during this development of IoT applications, we need we have to reduce our development time, and for that purpose, people developing such kind of development board. Otherwise, after once your development done, then after we can use only either this chip or we can use this breakout board to reduce cost again. So this is all this you people very well familiar with this board. So now again, I want to again check you what is inside this chip. If you remove this enclosure, then what is inside? Here, in case of this node MCU, you have two LED. This is one LED. It is at pin number D4, and here also one on-board LED is there. So this LED is again provided by this node MCU board, and this LED is part of ESP12 itself. This again already discussed by experts, but you people, you should very well know this GPIO number for programming purpose. Yes. If again we closely look at what is inside this, if we remove this cap, then if again we remove this cap, then it is only ESP8266. Participant try to understand, it is ESP8266, and this is nothing but flash memory. That's why I use this word, it is attachable. No on-chip flash memory available with ESP8266. And again, there is no hardware PWM available with this on-chip. And this is nothing but this component is crystal. So I hope you are getting my words and you are with me. And this is very important. Don't search. Suppose if you want to provide free RTOS support in your node MCU or ESP32, then don't search free RTOS for node MCU, because they people only know this CPU. So on the website, you have to search free RTOS support for Xtensa LX106 or Xtensa. This is very helpful to search free RTOS or provides free RTOS support or real-time operating system support to your particular CPU, because this library for any RTOS that is specific to microprocessor or microcontroller. So it is a microcontroller, but having, or not only microcontroller, but is SoC. Here OTA disable means over the air. If your over the air feature is disabled, then you require at least 512 KB of flash memory. But if you want to enable this OTA feature over the air feature, then you require 1 MB flash memory. That's why in case of ESP07, attachable memory is 1 MB, and in case of ESP12, attachable memory is 4 MB on chip, means this on module. These features again already covered. These are the limitation of no on-chip flash, no on-chip hardware PWM, and no hardware accelerators for security. That is again provided in ESP32. Again, I'm happy to share there are 4 variants: ESP12, E, 12F, and 12S. Difference is nothing but difference you can see over here. It is in antennas. Look at this PCB layer. So in case of ESP12F, 4 layers of PCB they people use, and in case of this ESP12E, 2 layers of PCB. So right now, whatever node MCU available in your hand, the people use ESP12E, but now then after they will easily replaced by ESP12F. These are the development boards that supports MicroPython. This is your node MCU ESP12 Pi board. In this Pi board, here this is a ARM Cortex, and also for IoT microbit easily we can place in any hardware, and it is also Pi Y with this LoRa support. Then after to resolve this limitation, people introduce this ESP32. So ESP32 is nothing but successor of ESP8266. So now I take you to this ESP32. So ESP32 is nothing but successor compared to ESP8266. It is high performance size, it remains same. It is nothing but again ESP32. It has Bluetooth that is not available in ESP8266, and it also supports this CAN that is very useful for building automotive applications. So if you closely look at this is again sorry for your 5 minutes because it is not part of your FDP, but it's very important to know this knowledge of ESP32 because nowadays our company is also interested in this ESP32 as well as it will resolve to issues of if you have limited GPIOs or limited ADCs, or again we can see this difference because in the case of academic purpose, students majorly focus on either Arduino Uno or Node MCU or ESP32. Then at last we will discuss difference between these three terms as well, and then we conclude in a which situation which one is good for us or for our student. So similar, this again, this is the big brother of ESP8266. Again, if you can see this module available in my hand, this is nothing but ESP32, and again with cable connection, it is Node MCU. Similar way, this is USB. Again, in case of Node MCU, earlier Node MCU 0.9 version is there. They people use this CH340 for this converter. But in case of Node MCU 1.0, this CH340 driver replaced by CP2102 USB to UART converter. Similar way, reset and boot, that again significance of reset and boot that we discuss in hands-on session. Again, if this is nothing but ESP32 room. If we again remove this cap, this is inside of ESP32. Here we have this microcontroller or SoC ESP32, and this is your flash memory. Right now, flash memory of Node MCU and flash memory of this ESP32 same in case of room. But again, we can replace this 4 MB flash to 16 MB of flash memory in case of ESP32. But if you go through this literature at that moment, many times people announcing that it has onboard 16 KB of memory, but it is not true at all. Onboard ESP32 room has only 4 MB of flash memory. But yes, we can expand this memory up to 16 MB. This is a pin layout. So very interesting thing of this ESP32, you can see what is this inside this chip. So if you again see inside this chip, it has SPI, I2C, I2S. There is also I2S is not available in Arduino Uno. It has CAN support, 3 UARTs, Ethernet. Again, if we want to build some remote control based application, so without any sensor, you can build this application as well because it has inbuilt this IR, PWM. Temperature sensor is also available inbuilt, 9 touch sensors available, 2 DAC that is not available in Arduino Uno as well as Node MCU. And very interesting features of this ESP32, it has 18 channel ADC, sorry, 18 ADC, but in case of Node MCU, we have only 1 ADC. So in your development of IoT applications, if you have 5 sensors, and I assume 5 sensors having this category of analog category, then we need at least 5 channel ADC. At that moment, if we have Node MCU only, then we have to find out some I2C based slave that is available in market, and it will increase our cost as well as it increase our PCB area. But we can resolve this issue easily if we can replace this Node MCU by ESP32. Similarly, this real-time clock portion, this AES module or cryptography hardware acceleration is on chip available in case of ESP32, that is not available in Node MCU as well as Arduino Uno. One interesting feature of this ESP32, it is a 2-core microcontroller. Now, what is the use of this 2-core microcontroller? So again, I always announce If in case of your operating system, we always use one word, multi-processing. If we want to achieve multi-processing, we require multiple CPU. So we always heard that quad core, dual core, quad core, hexa core, octa core. So again, in case of microcontroller, we have only one CPU, and with help of this one CPU, we can achieve only multitasking. We never achieve multi-processing with help of CPU. So our embedded system is nothing but we analogize with our human body. So God gives us 5 organ or 5 sensors. That is our eye, nose, ear, tongue, and skin. These are our sensors. Then CPU is our system core is nothing but our brain is our CPU. Then we have actuators, our hands and legs for fighting and do many things for these actuators. But human is again God's gives us only one CPU. But assume suppose right now only one Cygnus is here due to this is a gift from God. Assume suppose we have two JJP or two Cygnus, then what happened? One Cygnus deliver lecture over here, and second Cygnus can enjoy anywhere with his wife. Now assume suppose we can again we can ability to quad core, means we have 4 core at a time. We can generate this quad core 4 clone of Cygnus. So one Cygnus over here to deliver this session, second Cygnus with his wife, and again I have 2 spare for my 2 girlfriend. But again, God knows this problem. If I impart or inculcate this facility to this human, then what is the problem? And that's why God gives us only one CPU, and with help of this one CPU, that's why human is a example of multitasking, or human can do multitasking, not multi-processing. So in case of operating system, in case of our Linux, we have multiple CPUs and we can assign this job to multiple CPUs. But once we look at the microcontroller, and majority of these embedded systems and these IoT fields for interface these small sensors, we use microcontroller. And what is the drawback of microcontroller? It has only one CPU, and through this one CPU we can achieve only multitasking, not multi-processing. And that's why this RTOS role comes into picture, real-time operating system. So through this using by help of this real-time operating system, we can achieve multitasking with help of single CPU. But here it has two core. That's why we can achieve multi-processing along with multitasking. Total GPIO in case of that is discussed. We discuss in a different section. Okay, if you look at this chip, then this is ESP32 DOWDQ6. Meaning is that it is dual core, 0. This is not O0, 0 embedded flash, Wi-Fi, dual mode, Bluetooth, and is a packaging. It's only the 6 x 6 mm only. And with this 6 x 6 mm, everything is integrated that is demanded by IoT applications and IoT world. So this is again, and again it has a good amount of flash memory as compared to Node MCU. So if we're talking about this GPIO, so in case of Arduino Uno, we have 20 GPIO. In case of Node MCU, total you have 17 GPIO. In case of ESP32, total you have 39 GPIO. Now, if someone raises a question, sir, I have Node MCU, but it has only D0 to D9, RX, TX, and only one A0. So if you apply your childhood mathematics, then this is nothing but total, it is 8. So total it is 9, 10, 11, 12. But this 5 pins used for to interface this flash memory with this chip. That's why 12 plus 5 equal to 17. Similar way here 34 plus 5 equal to 39. But here there is a on-chip flash memory. That's why we can use total 6 ADC pins and 14 digital IO pins. In case of absence of ADC, we can use these 6 pins as a digital as well. So this is crystal. Features, if you're talking about or look at these features of ESP32, it's very nice and it is already covered in our previous slide. These are the different ESP32 development boards available in the market. So here you can see with camera. Here you can see with this I2C based LCD. This is nothing but simple development ESP32 development kit. This is nothing but ESP32 development board manufactured by SparkFun with this LiPo battery charger. And this is very nice module. ESP rover kit. This cost is around roughly without LCD. If you don't want to buy this LCD, then its online price roughly approximate 2600, and if you want to buy this with LCD, then roughly its price is 3000. But it's very nice board. It gives this each and everything, and again it's again larger or more offer more feature than ESP32. Yes, this is our interest. Now coming towards the point, if you want to develop this firmware, then what are the possible options? So here two words are there. One is called prototype and second one is called professional. During this prototype journey means right now you are beginner. I assume we are very child in this IoT world. At that moment, either people can start their journey from Arduino IDE or Arduino framework. But here you people need some knowledge of C or C++, because all this library written in Arduino that is in C++. But again, we can it supports C as well. So no worry at all. But someone know this MicroPython and it's from computer science background, and he or she is not knowing anything except Python, then they people choose this option MicroPython. So for prototype purpose, either we can use for this Arduino IDE or Arduino programming or MicroPython. But once these students enter in this industry, then they people use ESP IDF. Express if, this is ESP means Express if Internet Development Framework. Internet Development Framework is officially designed by this company itself. So along with this ESP IDF, they people develop their application in either Eclipse or Visual Studio. So this is again professional. If our students place in MNC, then MNC always prefer either Eclipse or Visual Studio. So Visual Studio right nowadays people more prefer due to this open source facility. In case of this, Eclipse is community version is also available, and company has to procure this Eclipse, and they have some problem during this audit, and that's why many of industry right now prefer this Visual Studio. And believe me, if you know only this Visual Studio, then there is no need to know any ID for your C++ development, the C programming development, C++ development, C# development, Java development, or Python development. So right now our agenda is either you can use C, C++, or Python, but it support one more language as well, eLua, that is called embedded Lua. Then what is the difference between these two, Lua and C, C++, Python? This is a concurrent language. This is a concurrent language, and we have to use this ESP loader for this eLua. But our today's agenda is MicroPython. Then what? Why MicroPython? If you're not knowing this anything about this C and C++, if you want to start build your application with this ESP32 or Node MCU, we have knowledge of Python, then we can easily start this journey of this IoT. Then again, one more IDs also people are using, but here free version also available as well as community version is also available, Platform IO. So again, Platform IO is used for the development of C, C++, Arduino Sketch as well as Python. But here again, community version is also available. So in industry right now, people may prefer either Eclipse or Visual Studio, Visual Code, VS Code. But once we are starting or we are learner, then we prefer new Pycraft, because we have worked for this ESP loader. We have worked with this VS code. We are working in this Eclipse. Means all these IDs available in market. We tested our code in every framework. Meaning is that we use this Arduino ID. Again, we develop the same folder or all these applications in Lua as well. We are development in MicroPython as well, and we develop these applications using this ESP IDF as well. So, what is the advantage of ESP IDF? If we develop this same a blinking code using Arduino ID and same code, suppose I am developing using ESP IDF, then here my code size is 300 KB and here my code size is only 145 KB. So if you want to look at it optimization of your code, that is industry demand or product demand, then you must go with this ESP IDF. But prototype is also important. It reduces your development time, because very nice libraries available in Arduino ID, also nice libraries given by this Python, and you people very well know, those knowing this Python is a very easy to learn, and development in Python require very less time, and that's why right now our session on this MicroPython. So now jump to this. Before starting this let us conclude which one is better. Or suppose if your student want to purchase this development board and he or she asks which board I want to purchase for my project. So right now I never prefer Arduino Uno, because there are so many reasons I have to reject this. Because if you look at this flash memory, advantage of this flash memory, it is an on-chip flash memory, but it is only 32 KB. So here in case of Node MCU 1 to 4 MB attachable, and here in case of ESP32 we have attachable 4 to 32 MB. So in these three case, this is our obvious choice. If we look at the RAM, so RAM is required during this runtime. Again, if we want to perform this free RTOS or RTOS programming in our module, then again it requires huge memory. Similar way, if we want to provide security at a hardware level, again it requires huge amount of memory, and that is provided by ESP32. That is here it is a very less. So if you want, if we develop some security library in Node MCU, then it might fail due to this SRAM during running of your code during execution time. As you can see here, frequency is also higher in case of Arduino Uno and Node MCU. Architecture wise, both are 32-bit. Yes, as a Gujarati, here difference comes into picture. Cost of this board is less as compared to ESP32. But if we look at this feature offered by ESP32, and that is really useful in our project, then if we integrated this all these features along with this Node MCU, then cost is too huge if we use this Node MCU. Then programming language, it support C, C++ only. But here all programming of ESP8266 is not Node MCU. Listen to me carefully. All programming that is available in C, C++, Lua, Python for ESP8266 valid for ESP32. But all programs of ESP32 is not valid for ESP8266 because it has limited GPIO, limited ADC, because here only one ADC. There is no Bluetooth, there is no touch sensor, Hall sensor, and there is always single core. Apart from it, one more protocol, sound protocol, I2S, that is not supported by Arduino Uno, but this Node MCU and ESP32 support provide this support of I2S. Here it has 3 UART. Here it has only 1 UART. So if we compare these 3 in side by side, then ESP32 is obvious choice for student to build that project. But don't worry, as a faculty member, we should cap this both. So those participants recently ordered this Node MCU, don't panic. As a faculty member, we require both the modules, Node MCU and ESP32. And again, one very interesting thing in this Node MCU and ESP32, here ADC size is only 10-bit, and here size of ADC is 12-bit. Then be careful if your student prepare their or suppose interface any analog sensor with Node MCU, and he or she email this code and you are tested your code using ESP32, then answers in this case definitely differ. Why differ? Because here difference in size of here 10-bit and here 12-bit. Again, one more interesting thing about this ESP32, it has 6 ADC. Here it is a 16 ADC, but here we have two ADC, means multiple multi-channel, and these two ADC divided again 8 channels. So if we look at communication side, and if you want to measure phase difference of two pulses at that moment, we have to sample this value the same time, and to sample this value same time we require multiple ADCs, and these features again given by or provided by ESP32 that is not available in Arduino Uno as well. Arduino Uno has only one ADC having 6 channels, but ESP32 is dual core, and that's why we have multiple ADCs and multiple channel. So here I conclude that ESP32 is obvious choice. So if your student demand or ask question to you, sir, which board I prefer for my project. So initially, if you're thinking about it, you have only one ADC, then purchase this Node MCU. But along with it, if you want to incorporate this Bluetooth facility along with your project, or you want to again provide Wi-Fi facility as well, at that moment, here you have to buy separately HC05 module, and cost is around again 300, and if you sum up these two costs, then it is larger than ESP32, and that's why I always encourage to all these participants, if your student asks in your first year or second year, such sir, which module should I prefer, then for student purpose ESP32 is obvious choice. But let me tell you, for faculty members, you should have Arduino Uno, Node MCU and ESP32, then and then in your session you can demonstrate a comparison between these three modules, and you can easily come to know what are the pros and cons of particular board. This is our interest. So as per our agenda, smart application. In a smart application, we require firmware. Firmware is nothing but binary executable code. For the purpose, we can generate using Arduino IDE or Python or Lua. Now for the purpose we require framework. Now for framework, yesterday Vishnu sir demonstrated generate of this binary file or firmware using Arduino IDE, and today I'll demonstrate this how to generate this binary file using MicroPython. And last we have hardware. So there are many hardwares available in the market to develop your IoT applications, but to restrict to this FDP, this FDP is more focused on ESP8266, and I introduced one more board as well. There is industry demand and very nice, having very nice feature with less cost or low cost. So what is this MicroPython? MicroPython is nothing but it is not for microcontroller. This word says it is a micro version of Python, and that's why this is nothing but subset of Python 3.4. So again, those who know already this Python, so all syntax of this or all features of this Python is not valid for MicroPython, and that we are Gujarati, majority of is Gujarati, then we don't believe without demo, and that's why I'll demonstrate each and everything on my screen within a few minutes. So MicroPython, and very advanced, a good thing is open source, because Python is open source and MicroPython is a tiny open source Python programming language interpreter that runs on small embedded development boards. Now I announce this one word firmware. Try to understand, ultimately any embedded boards require this firmware. Firmware is nothing but this binary executable file that running your code. But here two firmware. One is firmware for your application, and second, if you want to run Python, so Python require interpreter. So first of all, we have to install interpreter in our microcontroller. I repeat once again, if we want to run or execute any program in our laptop or desktop, so first of all we install this Python interpreter from website. There are again many IDs are available for this Python. Similar way, if you want to take this same feeling in hardware, So first of all, we have to install this interpreter inside our microcontroller. Advantage: simple and easy to learn as compared to C and C++. Open source, hardware level, all these libraries are available: GPIO, ADC, UART, PWM, I2C, SPI. Even though yesterday sir announcing some MPD protocols, so all these libraries again developed, designed and tested by this MicroPython, and it is also integrated with your IDE. We can develop this application of embedded system using these modules, as well as we can develop IoT applications. It supports this socket programming for this client server mechanism. It supports extension software libraries also provided by this Python. Limitation is the only, if we compare with this desktop, then limited memory. And due to this limited memory, all features of Python is not incorporated into this MicroPython, and that's why this word MicroPython. It is a micro version of Python, and if we can again install or import this matplotlib for this data visualization. It is very nice library that is used in machine learning as well. But if we want to install this library in our small board, again it demand more memory. But as we know, it has only 4 MB of flash memory right now. Within this 4 MB of flash memory, we have to install interpreter as well as our IoT application. Means here we have to use this 2 firmware, one firmware for Python, and second firmware is nothing but application. In case of Arduino IDE, we require only one firmware, that is nothing but IoT application. So try to understand, here we are use this Python, and Python always use this interpreter, and to provide this interpreter facility, and one advantage of this Python, it is interactive, intelligent and interactive. So how it is interactive and intelligent, that again I'll prove in my demo session. So always your computer IT guys, this perform hello world. We embedded guy always perform first practical this blinking inbuilt LED. So if you want to start your journey with this MicroPython, and if your delivery boy deliver this Node MCU to you, now Node MCU or ESP32 is available in your hand, and you having your laptop and desktop available with you, then what are the steps that needed to run your first application or to blink this LED on and off in our system? So step number 1, first of all, again I announce we have to install. First step 0 is Python must be installed in our laptop or desktop or PC, simple. Once this Python and Python version again 3.7.x. Now latest one is right now Python 3.7.9, but it is a subset of this Python 3.4, but it is advisable you should install Python 3.7.x in your laptop or desktop. Then second, we have to install this Python inside our this tiny board as well. For that purpose, this firmware available online, and don't worry, I developed this nice document for you. You have to blindly follow this all steps, and you reach at your LED blinking program. Then after, we have to install this device driver for CP210X USB to UART bridge. That is needed in only Windows PC. If you have Linux, then there is no need to install this CP210X, and link is available over here, as well as I provided link in my document as well. Then after, now try to understand this flashing node MCU is needed. Here we are exploring 2 ID. One is ESP Loader, and second one MuPyCraft. ESP Loader is for eLua and Node MicroPython, and my MuPyCraft is only for support for MicroPython. So if again you want to explore this ESP loader, then first of all we have to install this firmware, means Python, in our this small board. Meaning is that once you download this binary file from internet, then we have to download or deploy this binary file inside this board, and for that purpose we have this small chip, that is USB to digital converter, through which we can upload this program in our flash memory. But here in case of ESP loader, there is no facility of what we can say directly flash this firmware from internet to directly board. So that's why we have to take help from this Node MCU flasher. So we have to download this Node MCU flasher, but don't worry, we always prefer this MuPyCraft and everything integrated inside this MuPyCraft. But if someone interested in development in Lua, then they must use ESP loader. So then after once this firmware is installed, we have to require some this shell, Python shell. Now to pop this Python shell or to interact with Node MCU via Python, we have three options: PuTTY, ESP loader, and MuPyCraft. So in case of PuTTY, we have to provide this comport that is again pop up after successfully installation of your driver. Then it's a Python prompt. So here it is nothing but MicroPython prompt. Similar way, in the second option, ESP loader, this is a screen of ESP loader. First of all, here we have to choose particular comport, and one interesting thing, by default it is Lua. So once you start with this programming, then click on setting. Once you click on this setting, one window will pop up and two radio buttons are there. Initially it is on this Node MCU. We have to initially this will check. We have to tick over here to develop this application MicroPython. But it is only for we use this ESP loader for developing application in Lua. For this development in MicroPython, we always prefer MicroPython for beginners. Once beginner, then after Visual VS Code. This is a screen, but don't worry. We have talked very much about this theory, and now it's demo time. So quickly go through this document. It's very nicely designed. So once this board is available with you, then prerequisites Python 3.x, internet connectivity is necessary, and this targeted board is ESP8266, but the same steps also valid for ESP32. Only one change is there, and right now we are performing these all steps in Windows 10. If Python is already installed in your system, then skip this step. You can directly jump to step 1. Otherwise, if it is your formatted PC fresh, then please first of all install Python in your system. It is right now only sake of simplicity Python 3.7.0, but you can install a latest one. Don't worry for that. Then double click on it. Simple. It run this install now, and don't forget to click over here. By default it is click. If it is not there, please check it. Setup in progress, and then lastly this setup was successful message will pop up. Then click on this close button. It will it is right now your Python in your laptop successfully installed. Now we have to install Python in our small board as well. For that purpose, first of all, how my Node MCU communicate with this PC? For that purpose, the people provide this USB to TTL converter, and here this IC is CP2102 USB to UART bridge. So go to this link, and in this link we have to download driver for Windows 10. Then unzip this folder. In this unzip this folder, you have come across this two files 64 and 86. Click on according to your 32-bit or 64-bit. Now make sure you have to, after this you have to connect your Node MCU with your laptop, because sometimes what happened, people are not connecting this Node MCU with PC, and then your students also announcing, sir, comport is not pop up. Then your first question should be, first of all we have to interface this Node MCU with this laptop, and here use this good quality of USB cable, because sometimes what happened, this small flat cable is not working. So that is again second point that is used for your debugging purpose. And if driver is successfully installed, everything is fine, then once you check this device manager ports, then Silicon Labs CP210X bridge COM4. Now it may be differ in your system, and once if you are working in laptop and you are pairing some Bluetooth, at that moment you have many ports. So remember this port number throughout your development. And if you forget, don't worry, go to this device manager, click on these ports and click over here Silicon Labs CP210X USB to UART bridge. Then step 3, that is very important. Download MuPy Craft IDE. It is very lightweight, no much memory is needed. Click over here, simply download one exe file. Now there is no requirement of installation, just double click on it, then this window will pop up, and this is nothing but our MuPy Craft IDE. I demonstrate all this thing with help of my board as well, because we are Gujarati, majority of participants, and without demo we don't believe anything. Now once this software or IDE available with us, our first step, we have to install firmware of MicroPython inside this chip. Right now again let me introduce here. Once is our application, but we right now want to develop our application using Python, and that's why similar way, once we install Python in our laptop, similar way we have to install this Python interpreter in our Node MCU as well, and that's why it is nothing but firmware. This is firmware is nothing but this firmware for to providing MicroPython facility inside my Node MCU or ESP32. So for that purpose, we have two options. First of all, go to these tools, one firmware. Here advantage of this IDE, there is no need to ESP flasher. If you go with this ESP loader option, you people require two software. One is ESP loader IDE, and second one we need this ESP flasher. But good feature of this MuPy Craft, we need only one IDE. This one firmware facility is integrated with this IDE. Let us see this, explore one by one. So here first select the board ESP8266, that again I'll demonstrate in a section as well, and similar way let me open this folder of my IDE as well. PC Rajkot ESP not see whatever I say this ESP loader. So this is for ESP loader. Once you click on this, it requires Java. So first of all, prerequisite Java should be installed. And talking about that settings, click on this setting button. By default is not MCU, meaning is that by default your IDE configure in Lua. But if you want to execute your code in a MicroPython, then you have to change this setting to MicroPython, and then you can start your script. But before that, we have to flash this firmware in our Node MCU. So that is very tedious job, and that's why we are not preferring this ESP loader for development of MicroPython. But if you want to develop your application, you can. There is no restriction, there is no thumb rule. Then after we have to choose appropriate port. We have to again select this baud rate and open, and then you can start your programming from here. But it is not today's part. So this is all about ESP loader. For that purpose, we require ESP flasher as well. Today, MuPy Craft IDE. So this is a please install source code pro font. If you can click on cancel button or OK button, that is fine. Then it is nothing but my MuPy Craft screen. And go to these tools here, boards. So this MuPy Craft right now support ESP8266 TP this pipe board, ESP32 again pipe board. This is a different version of this pipe board with ARM Cortex facility. So advantage of IT and computer peoples, this is a 32-bit architecture. It is very difficult to understand this GPIO programming or timer. If you want to build one LED blink application without this MicroPython and you are fully depend on embedded C, then we have to refer all SFRs associated with this GPIO as well as timer. Then and then you are in position to write a single application. Then it increases your development time, and Arduino is a game changer in this world. Then after everyone again, Python communities also look at for this thing about this board, and they people also launch their firmware to write or develop firmware for IoT applications as well as embedded applications. Here we have to choose first of all COM, and here we have to click on this burn firmware. But first of all, go through this document, then again we are performing a full demo over here. So click on this burn firmware. After this burn firmware, we have two options. So I'm talking about this tools, burn firmware. Here I have two options, MuPyCraft and user. So what is pros and cons of this MuPyCraft and users? Let us explore. Here we first of all we have to choose either ESP8266 or ESP32 right now. So if we are interested in ESP8266, meaning is that node MCU. So that's why I announced you have to remember this word ESP8266 rather than node MCU. Otherwise, we always find out node MCU in this window and that is not present. So what is node MCU? People very well know through this slide. Recall that slide. We have two options. MuPyCraft. So if you click on this MuPyCraft, at that moment it download this binary file in a backend side and automatically flash in a flash memory, but it needed internet. Then what is drawback of this MuPyCraft from internet? It always deploy latest one from internet. But again, suppose your interest is you want to download firmware according to your choose, means down version. Right now this version 1.13 is latest one, but we want to deploy this 1.12. Then MuPyCraft is not support. Second drawback, it need internet. मान लो somehow your internet connectivity is you lost your internet connectivity. At that moment, this user option is fine for us. So we have two options. Once we click on this MuPyCraft, it automatically download firmware from internet, then it erase flaws and burn into this board. Similar way, if we choose this COM port, second option, and once you click this, after this successfully or the all steps successfully there, click on this connect button and it will pop up this Python shell for you. If you achieve this, meaning is that your setup is done. Second option, user. So in case of user, first of all we have to go through this, we have to click on this link. It is an official link. Here all these versions are available. Suppose my interest is 1.12, then I have to click on this 1.12, this binary file downloaded in my PC. Then after, again go to tools, burn firmware, ESP8266, don't look at for node MCU, COM according to your system, click on user, choose and select appropriate path, then click on this OK button. And then after, there is one in previous slide there are 3 tabs, but here only 2, erase, flash and burn. In previous case download is also there. Similar way, ESP8266, and once again you have to click on this change button or connect button, it will take you to this prompt. Meaning is that we have two options, either MuPyCraft directly or user. And last Blink example that again I demonstrate using this my board. And last thing, this is important and not, and that you have to keep in your mind during this life cycle of MicroPython. Once we click on this download and run button inside ESP8266, means your application firmware is deployed inside this, and then after before disconnect node MCU, don't forget to click on stop button that I demonstrated. Don't worry for that. Otherwise we have to burn this firmware again and again. Simple. But we are Gujarati sir, ये slides पर पता नहीं चलेगा. Let's this demo time. I repeat once again, or I start my journey from scratch. This document is over. Before this, we have book, firmware, presentation program, and software. This software, double click over here. Simple, you can press either OK or cancel. Don't worry for that. Then first tools, burn firmware. In burn firmware, right now ESP8266. Choose COM4. Right now only COM4. But if you have laptop and you have many Bluetooth pairing, then it might showing many options. At that moment, which is appropriate, that we can check using device manager. Here MuPyCraft. Let us first explore this MuPyCraft. Click OK. Then 3 windows. Download, erase flash and burn. Right now it is downloaded this binary file. Right now it is erasing my previous flash memory, and this process shows that this binary file goes inside this chip. And if you look at my node MCU, this is my hand, one upper LED is blinking. What is that? So this binary code 0101 is writing in this node MCU, or sorry, flash memory through this chip or through this USB to DTL converter. So it requires hardly 2 to 3 minutes, depend on your internet. Okay, once done, then click on tools, serial, COM4, and once you select this COM4, see here, terminal is there. Second option, let me explore. Second option, tools, again burn firmware. We have to select this ESP8266, COM4. Here, instead of MuPyCraft, users. Choose. I have to choose firmware. So yes. So you can see over here, I have this firmwares in my system, and right now I would like to deploy this version 1.12 instead of 1.13. Then again, OK. Now it will pop up only 2 tabs, erase flash and burn flash. Wait a moment. And again, once you click on this tools, serial, COM4, or this will pop up. But here version 1.12, in a previous case it is a version 1.13 or whatever latest version available, that one. But only drawback is there if net is not there, and if you want to deploy or flash this MicroPython firmware inside your node MCU, we have to have explore this user option. Now to check whether this board is working condition or not, file, sir, please acknowledge this board in my hand is visible to you or not. Hello.
Sir, visible. Not visible here. If you can keep it near to the camera.
Now?
Yes, sir. Now it is.
Okay, thank you. So right now go to this. This is only testing purpose. Examples, basics, blink. This is a blink option. Right now I'm not interested in all syntax. Then after click on this button, download and run. Once you click on this download and run, I hope, sir, one blue LED is flashing, blinking. Please acknowledge.
Yes, sir. Yes, sir.
So if you reach up to this, meaning is that everything is fine and you are lucky. Your board is set up, your software is set up, and you haven't this damaged board, you have this fresh one board. My tip is there, or important note is there, click on the stop button before disconnect your node MCU. Now try to understand, it is a real practical. Again I click on this download and run button. This LED is blinking and I click on the stop button. Now I disconnect this node MCU from my cable. and again I reconnect this node MCU with this. And what is magic? Your program is gone. Means previously we run this code that is blink.py that is installed in flash memory, and once we disconnect this code and again reconnect, then my code is gone. So very important thing behind this MicroPython. Again, suppose if I click on this run button, before that I have to open this serial port and again click on this down and run button, it will come back. But what happened once you deploy this your node MCU in your AC and you are using this MicroPython to develop this smart AC application, then each and every time you have to click on this play and run button. So again, keep in your mind, during this development purpose this Python file name .py is there, but once we want to deploy this application permanently inside this node MCU, at that moment our file name should be main.py. But before that, let me explore some features or difference between MicroPython and Python. Here this is a clear option. Using this clear we can clear this console. This is our editor. This is our device tree. Now click enter. Suppose those who are knowing this Python, a equal to 2, and if we check this type of a is nothing but integer. Similar way, suppose a equal to 2.5. So Python is intelligent. Previously it is integer, and right now if we check type of a, then it is float. Similar way, suppose Python is also installed my system. Understand what is the difference between this Python and MicroPython. Same thing, suppose we can perform in this white window, it is my system Python 2. Similar way, if we type similar way a equal to 2.5 and type a simple float, but difference comes over here. Suppose a equal to 2 plus 3j. Support complex variable as well or complex data type as well, but here try to understand a equal to 2 plus 3j, same, and trace back. So this is the difference between MicroPython and Python. So MicroPython is nothing but it is a subset of Python. All these features of Python is not provided in MicroPython due to only one reason, that is limited amount of memory. So here again you can check this or list. Suppose a equal to list. So here I declare one object that is a list, and here I check this dir of list. Here you can say it's about only this kind of methods. And same way, suppose here in Python list and dir a, you can see the difference. Yes, so many inbuilt variables are there and many methods, but these all methods not supported by this Python. Your comparative people program, first program, print hello world. Sorry, hello world. So this is the thing, but your simple Python. So why it is interactive? So here we have Python shell, and believe me, here we are running our code using node MCU or this microcontroller. And to get this cell, this binary file is there, and then after once we click on this button download and run, this binary file of this blink.py is deployed in this board, and we can see this kind of this LED on and off stuff. But if we want to store permanently in this board, go to this file, new file, similar way. Develop your application on application. So here we have two LEDs on board. One is at pin number or GPIO 2 and second one at GPIO 16. So right now I'm using for this GPIO 16 instead of GPIO 2. So this upper one LED is GPIO 2 and lower one LED that is in my slide here. It is nothing but GPIO 16, and let us explore this GPIO 16. file, save it main.py if it is your final one file, or if you want to permanently store inside this flash memory. Now again stop. Now again I click on this down and run. Sir, please acknowledge me. This lower LED is right now blinking. Yes or no?
Yes, sir. Yes, sir. It is blinking.
Okay.
It is blinking.
Okay. So this is nothing but onboard LEDs. So in case of this node MCU, we have two LEDs on board. One is for on-chip module LEDs, and second one is this is provided by this PCB of a node MCU. Now again I stop it. Again I disconnect this board from this my cable. Again I reconnect, and you can observe this LED is still blinking. Yes or no, sir?
Yes, sir. Yes, sir.
So in previous case, if when I loaded this blink.py, at that moment, what is our observation? Once we disconnect this node MCU, again we reconnect, our firmware means application is gone. So that's why, according to this by default setting, if we want to store or run this application in our flash memory, then we have to prepare file main.py instead of any.py, means file.py. During development you can assign any name, but once you want to feed this into product and you don't know how to change this boot setting, then you have to remember my last file name should be main.py. And never disconnect this node MCU directly before place on the stop. Otherwise, what happened? We have to reinstall this firmware again and again. So that I also demonstrate. If okay, first of all, we have to open this serial port. Again, this is your conventional C. Right now, see this problem. I forgot to click on this stop button, and right now it demand me reinstall this one firmware. So again, if I would like to work with this MicroPython, I have to perform this same job. And that's why this two important part with bulb. This bulb is nothing but it says that Dimaki Bati Jana. Now very interesting thing that I would to explore or demonstrate. Your program writing of this program of by you or your student should be professional one. And what is the difference between this professional programming and this normal programming? So you can see over here, or you can compare these two programs. This is your again LED blinking program, and this one is again your blinking file. But before, okay, so first of all discuss this, and lastly I demonstrate one replace the GPIO pin. You can replace this pin number 16, sorry, to any pin. So, suppose we have, yes, GPIO, let's say an example 4. So if we remove or if we replace this pin number 16 by pin number 4, then, and again this prompt is that I downloaded this main.py, but there is nothing is happening in this board. Why? Because there is no LED at pin number 4, and if I interface this action LED at pin number 4, we can see this output, it is nothing but D2. So quickly I interface this LED. And you can see over here. Sir, it is visible?
Yes, sir. Yes, visible. Yes, sir.
Okay.
It is blinking.
Okay, thank you. Now, interesting thing about this programming. So always encourage your student, or always adapt habit to write professional programming rather than this conventional programming. This is your conventional program, and it is the same program, but this is your professional program. And again, it gives same feeling of your if I replace this blink function by loop, then it gives me same feeling of Arduino IDE or Arduino framework with help of Python. So here we are defining this function setup. Here we are for defining this LED blink, and here. So again, those who are this fresher in Python, don't read this program from this line main. It is not like that. This is not like that. Your Python programming always starting from first line. Your Python programming is always starting from first line. Sir, if time permit, then I require is 2 to 3 minutes to explore this main, and then after question answer session for 5 minutes.
Yes, sir. Yes, sir. Please continue.
Okay. So try to understand this is a very important concept, and after attending some courses on Python, many faculty members or students having doubt, because in many program of Raspberry Pi always you come across this. So let me take you through this simple blank slide. In case of Python, try to understand every Py file. Suppose I have 1.py. I have 1.py. It is nothing but library for another file. I have two files. One is called 1.py and second one is called 2.py. And what is our objective? Right now, I want to take you to difference what is the significance of this if underscore name underscore equal to main. So if I writing only one line, this print hello over here. So my Python program always starting execution of this Python program only first line. In case of C, as we know, our operating system or compiler start this running of this program from main function. But there is no concept of main in case of Python, and Python always start execution from first line. There is one dialogue, famous dialogue. लाला कभी लाइन में नहीं खड़ा रहता, लाला जहां पे खड़ा रहता है वहीं से लाइन शुरू होती है. Similar way, ये लाला यहाँ पे है और first it will start this execution from over here. Now, as I said, this is nothing but library for another file, and here in this 2.py I prepare or I import it, import 1, and if I executed this line, then my output of this program is nothing but hello. Surprise, there is no printing statement over here and my output is hello. Why? Because execution of this Python program is always from first line, and first it will import 1, meaning is that first it will execute this 1, and in this one this print statement is outside or is first statement, and that's why your output is hello. I hope you people are with me. And suppose if you don't do this thing, again def is nothing but def is one function or function concept in Python. Def suppose function, and it doing nothing but suppose print calling from 1, print calling from 1 statement inside your function. And as we know, we have to call these functions if you want to call this. So if we again call this function over here func, meaning is that now if I see output of this file, then it display hello as well as calling from 1. Now try to understand, if I run right now this file, and if I added one more line print, let's say example world, then what is output of my this file? First it again execute this file 1.py, then it display hello, then again it call this function, and again my output is hello calling from 1 as well as world. Now important concepts comes into picture. If we are preparing this library for this other file, at that moment this any statements always all statements inside this dedicated function, and we have to decide origin or starting point of our program, and we can achieve this with help of if main. Now try to understand what is the significance of if main. In first case, suppose in first sense, if I keep this function over here, then it is nothing but if conditional statement, if name equal to main. try to understand. Once I execute this program, listen to me carefully. Once I execute this program, at that moment, this is your internal Python variable. This is your internal Python variable. This your compiler or interpreter assign underscore main while executing this 1.py. So now execution of this program is like this. First print statement over here, that's why it have print hello. Then def is a function on the definition, then skip it. Then here function calling. So it call this function calling from 1, and here it check this condition if underscore name underscore equal to main. It is true because right now I'm running this file 1.py, and whatever statement, suppose print by. So by will print over here. Try to understand. By will print over here. Now I imported this file in 2.py, and now try to understand import 1. Import 1. So right now import 1, it has again its on main if condition. So if I executing right now this file, at that moment Python interpreter assign main to this name, and here my Python interpreter assign file name to this name. Meaning is that during I import 1, in case of this underscore name, it replaced by 1, not underscore main. In the previous case, if I running this 1.py, at that moment this my Python interpreter assign main to this name, and that's why main equal to main true, and that's why this print by. Now try to execute this import 1. First of all, it print hello, then it is a function definition. It is function, then calling from 1, and here print by is not over here. Why? Because here once it check this condition 1 equal to main false, and that's why it not printed anything. So if I place this func in this, if I call this func in this, and also if I remove, if I remove this print statement from here, then what is output of my this file? By as well as calling from 1. But import 1. Now what is output of this file right now? Only world. Even though print by and function over here, but what happened? Once it run this import 1, here it is a function definition, nothing to happen. Then here it check this if condition, if name underscore main, but in this case name is assigned to 1 and 1 is not equal to main. That's why this condition is false and it not permitted to enter this body of if, and it again come back over here and display print world. And that's why it is a humble request. We have to write Python program very careful. It is not like C. And here it is an indentation. There is no concept of curly braces. We have to use this indentation. And that's why in case of this VS Code, it automatically indented, and it is an open source. That's why professional one use either Eclipse or VS Code. So I hope you are getting my words, and that's why write such kind of programming, or even though you know this Python, so always try to write down professional program. Always encourage your student as well, because initial level they adapt this professionalism, then it's very easy to cop up in industry. Otherwise it's a bit difficult at a fresher level. And before ending my CS1, so I completed my content, but the last thing we have again, it's not related to technical, but again we have Shastra, that is called, we have Dharma Shastra, then we have Artha Shastra, and similar way in my words we have Engineering Shastra, and I define this Engineering Shastra only 3 layers. Layer number 1, information layer, that is called only question arise from what. Layer number 2, that is called knowledge layer. If you ask any question from why, and student, or if we have in a position to answer of this why, then we have knowledge. So in the Indian industry, in an Indian industry, in a first interview, they people look at only these two layer, information layer and knowledge layer. But once the students placed in this industry, then third is very important layer, applied knowledge. That is how, where, and when. If we have this question of these three questions, how, where, when, we have this applied knowledge, and right now all industry demanded this skill in our students. So according to me, this is my own perception, engineering Shastra I divided only three layers: information layer, knowledge layer, and applied knowledge layer. So if you want to judge ourselves whether this topic or this subject I know or not, so first of all we have to ask this question: what, why. Up to interview, this two is fine, but in my career I seen very cases that after 1 year they people or students lose their job due to lacking of this knowledge. And here only one thing is that involvement, or they have to dirty their hand. Otherwise they people never get this experience. They people know this word, they people know this why, but once task is assigned to student or engineers, and due to lacking of this applied knowledge, they people are not able to develop that application. So if I summarize my session in a simple word, there is nothing but, first of all, we want, our target is application, smart application. For the smart application we require firmware. Firmware is nothing but binary executable file. For the purpose we require framework. So Arduino framework, or you can go with this MicroPython framework. Similar way, once the student or you people familiar with this firmware or framework, then switch to ASP IDF. That is from industry demand. And then this firmware, or sorry, framework is all for hardware. And in hardware we have Swayamvar. In hardware we have Swayamvar. So today's session I only explore these microcontroller based IoT devices. And again you have more session for this SoC based or SOM, system on module, Raspberry Pi single board computer. You have session all as well. So uses of this microcontroller based, MPU based SoC or TPU and GPU is all about based on your application and your requirement. And to explore this layer, you should require these fundamentals of embedded systems. Thank you very much. Thank you very much, sir. Again, if participants having any doubt, so I'm happy to resolve that query. Thank you very much to listen me patiently. Yes, sir.
Thank you very much, Dr. Jignesh Padalia, sir. You have provided, in-depth technical information of MicroPython and how to program firmware with a different type of IDE, ESP loader. Participants are having any doubt, any questions, you can unmute your microphone and ask directly to Dr. Jignesh, so that he can clarify your doubts.
Hello, sir.
Yes.
Sir, actually 8266 is used for interfacing our hardware with the internet, right?
No, sir. It having ES. What is ESP8266? Let me tell you this. ESP8266 is nothing but inside this ESP8266. It has all features of microcontroller along with Wi-Fi facility.
Yeah.
In a single chip. Meaning is that suppose yes, sir.
Yes, we have demonstrated the LED on and off on the hardware, but it is not demonstrated through the use of internet and all these things.
So it's a limitation of my session. I have only 1.5 hours. That's why. Otherwise, if you see my folder, so again, out of this my 100 workshops, I have conducted 5 HTTP of 6 days, 6 hours per day, and I'm only one tutor. So in it is a programs. In programs, We have this Blink, Serial, Digital, ADC, PWM, Wi-Fi, online server, MQTT, ThinkSpeak, Android, Google Spreadsheet, Twitter, each and everything you can do. But due to this time limitation, my job and whatever portion assigned to me by this coordinator is only MicroPython, getting started and installation. That's why.
Okay, sir. Thank you.
Otherwise, we can do very nicely in this with ESP266. But if you want to achieve this Bluetooth, so in case of Bluetooth, we have two interface external HC05 with Node MCU. But if you with ESP32, the available in a single chip.
Sir, can you suggest some reference books in this line?
I posted in this channel.
Okay, sir. Thank you.
Other questions? And again you can see this again. It is my FPGA board, and people using this ESP266 along with FPGA. So this is a purely VLSI board. But to achieve this capacity, this FPGA application, people are developing some kind of board, and they use people either ESP01 or this ESP12 integrated with this kind of development board. So this is Spartan 6. This is Spartan 6 chip with this category of FPGA. Yes, any other questions? Otherwise, my robots say bye bye to everyone.